I'm going to show you kind of my techniques, or anyway, for getting the data into a good state for handing off to the Seabed classification. At that point, I'll give control over to Matt, and Matt will walk you through the best practices for working with the classification feature. Okay, so at this point here, I'm going to go ahead and I already have a project here on my in my main window here. Let's just take a quick look at it. I've got this called SC webinar for Seabed classification webinar, and I've got the approximate position set up. So I'm not going to go through that, but instead what I'll do is just go and start to import some data. So let's go under the Post-Processing tab and then import Sidescan files. And I've got a folder here with some SDF files today. It doesn't matter what the input data type is. It could be JSF from EdgeTech or XTF from almost anyone, Marine Sonic, whatever the flavor of Sidescan files you have. It doesn't really matter. It's the important thing is to get the data in and then get it in a state to run the Seabed classification. So this is about there are 9 files in here, and it's a little bit over 4 gigabytes of data, so I want to get that started. The Klein, this is a Klein 3000, and the data was recorded with Sonar Pro. We didn't record it, and because it's a dual frequency sonar, I want to import the high frequency channels because I want a nice high resolution mosaic. So I'll stop blabbing on and get that kicked off because that's going to take just a minute or so to run. While that's importing, I just wanted to pass along a couple of things, and that's if you have questions along the way, please use the chat button there to submit them directly to the webinar. And then at the end of the webinar, we've hopefully allocated enough time to answer the questions. If we get too many questions, then we can respond by email in a follow-up session. I also can dispel a couple of questions that we get a lot of the time about the functionality in Seabed classification. In SonarWiz, Seabed classification only works with Sidescan data. So if you have sub-bottom data, we can't generate any classes for you there yet. We are preparing to make another big development push on the Seabed classification features set at the end of the year. So if you have some suggestions or you see things that you think are good ideas, we'd love to hear about them, and this is a good time to pass them along, as we'll be putting the hood up on that again probably in December. Okay, so while I was yakking there, we got the initial mosaic that came in, and I'm going to get rid of the stuff that I don't want. So this line here, this sort of disconnected at the end of the mosaic, I'm going to get rid of that. This one here and this little guy up here. So I'll just select those and then say delete. Okay, so this is where we're going to start. And in SonarWiz, if you've ever used it before, you know the things that we're always harping about are kind of the navigation, bottom tracking, and layback. This particular data set was recorded with the fish position, so we're not going to do layback today, and the navigation is obviously looks pretty good here. So the thing that I am going to work on, though, is the bottom tracking, because it's really important to get the bottom tracked correctly and to get the gain processing done successfully. So we've got, after deleting out the little lines that we didn't want, we've got 6 lines left in this mosaic. And on the left-hand side, I've got the SonarWiz File Explorer here, and so I can select lines here, and you'll see that they highlight in the map. I've already looked at this data, obviously, in preparation for today's presentation, and I know these first 2 lines are fine. I've looked at the bottom tracking in there. But let's go through the rest of these 4 lines here and just take a look at some of the issues that came in with the data. Overall, it's pretty good. The blue line here in the SonarWiz bottom tracker represents the altitude that was recorded with the data in the field. And you can see that for the most part, it's pretty good. But as we scroll through the data, I'm just using my wheel on my mouse to scroll through the data. I'm not sure how well this is showing up in the webinar, but you can see that somewhere down here near the end of the file, there's a couple of spikes, and the SonarWiz bottom tracker has got manual mode and automatic mode, so I could retrack this whole line if I wanted to, but what I want to show you today is just quickly to use these insert button to insert and remove to delete a section of the bottom tracking. So what I did there was I used my right right mouse button to drag a box around the area that I wanted to delete. And essentially what's happening here is that the bottom tracker is interpolating from the top of the box down to the bottom of the box. So if you have a spike, normally all you need to do is just drag that box with your right mouse button. And since it's interpolating from the top down to the bottom, your work is done. Occasionally, if you've got a depression or something or a hump in that box, then you might want to come in here with your left mouse button and insert 1 or 2 points. Again, that's not needed here, but I just wanted to show you those functions. Okay, so that's really it for that line. So I'm going to save, actually I'll use save and next, which means store this file and load the next one up in the series. So again, this one starts off with a couple of more spikes. So I'm just going to go in here and use my right mouse button to drag a box and get rid of those guys. And there's a few more spikes down here. I don't know if you guys can see what I'm doing here very well, but I'm dragging a box around these different spikes and just cleaning the bottom tracking up. And the rest of the file looks pretty good here, I think. This is kind of the most tedious part, but it's also a really good step. I mean, we do have an automated batch kind of unsupervised bottom tracker that you could run. But I think it's a good idea to have a look at your data so you know what you got. And yeah, it is a bit kind of tedious, but that's sort of what we do is we want to look at the stuff before we process it. There's another spike here. And another one. And it kind of familiarizes yourself with the data so you know what you have. Okay, I think we've got one last file here. Just scroll through here. It's looking pretty good. Okay, and right at the end here, kind of tails off. So again, I'll use that same function, drag a box around, and insert a couple of points. There we go. Okay, so that's our bottom tracking. Now, one thing that you might notice, especially in the shallow end of this mosaic, let's move this off to the side here so you can see. This area of the mosaic, kind of the north section here, you can kind of see it's very bright and reflective, probably a hard bottom. And as you go to the southern end here, the kind of the southwestern end, you can see that this is probably softer sediment and not as reflective, right? And that kind of shows up in the bottom tracker. You can see that the blue line, between the blue line, which represents the sonar altitude, and where the bottom actually starts, there's a little gap. So the tracker was just wasn't quite digging in deep enough in this shallow end. So I'm going to save the bottom track, and what you might be able to see if you kind of watch real closely down at the bottom is in the background, SonarWiz is reapplying the slant range correction based on those altitude changes that we made. And so it's kind of closing up those little spiked areas. What I want to do to address the little gap is I am going to use the batch bottom tracking tool that I mentioned. And if you right-click on one of the sonar files, the top menu item there is Sonar File Manager. And what I'm going to do is use the button that's called Batch Bottom Track. But I'm not really going to track the bottom. All I want to do is offset the bottom track. Hold on one second, I just need to close my office door. Okay, sorry about that. Doing this from home today. Okay, so I want to put an offset, and actually about 7/10 of a meter is good enough just to nudge that bottom track down a little bit so it's closer to the sediment, so I get rid of that gap. So I'll put in my offset. The lines that I want to apply to, it's basically all of the lines are selected, and then I'll hit the Apply Offset button. So without you having to look at the file and do this, you can also do this step in the bottom tracker, but without having to actually go in and look at each one of the lines. You can do this through the Sonar File Manager using the batch tools. Okay, so again, you might notice that there's a little adjustment going on as we applied that batch offset. Okay, so the next step here is to actually apply some signal processing. And Normally, if this would also be where we would do layback, but we would do that probably before we did the signal processing. But we're gonna skip the layback because this data doesn't need it, and also in the interest of time, so I can get this over to Matt to take over. Okay, so let's talk about our signal processing. The first thing I want to do is kind of point out why we want to do some signal processing. And if you zoom in a little bit on the mosaic, you can kind of see the classic problem with Sidescan reflection, and that is that you tend to get a dark return right there at the nadir, and some bright areas at the nadir, and then the data kind of falls off, and as you get outside towards this this far edge, you can kind of see bright here in the middle, and then fall off in the edge. It's just a classic sonar problem. It has to do more with the geometry of the Sidescan than anything else. So what we're going to do is we're going to click on any line. It doesn't matter which one we start with. So I'll right-click on a line, and then I'll choose the Settings button, and that'll pop open our gain settings dialog. And what we're going to use today is the EGN function. So this is kind of our newest function for doing gain. It's EGN is an acronym for empirical gain normalization, and it was developed by a guy named David Finlayson at USGS. And essentially what it does is it takes all the samples that you have in your entire mosaic, and it maps them for each transducer, port and starboard side. It maps every sample according to range and altitude. So in a sense, you're actually kind of forming a beam pattern image for each transducer, and then that table, those two tables, actually, one for port, one for starboard. The values in the table are used to correct the Sidescan return when it's applied. So anyway, it's a little bit like geocoder because you're kind of doing the same thing, but you're doing it empirically. You're looking at all the samples in your mosaic and then going back and applying them versus modeling all that stuff up front. But anyway, that's enough about EGN. It's another topic for a webinar probably. So we'll just take and now we've built our table. We're going to apply that EGN to this one particular line. And it's kind of a slow process here, but let's just kind of pan up here just to show you the difference. So this line here that's got the blue perimeter around it is the one that we just applied the gain to, and I'm going to use the SonarWiz move function just to slide this line over temporarily so we can see the adjacent line to it, and you can kind of see the difference. So what we're striving for is to try to get good normalization across track. So we want an even tone from the nadir all the way out to the far field. So this line, again, the one with the blue perimeter here, has got the EGN applied. This one here does not have the EGN applied, and you can see the difference. It's got the bright nadir, kind of weaker far field return, and not very well normalized. So when you're making a mosaic for the purposes of Seabed classification, you're trying to remove all of that geometric effect that has nothing to do with the actual bottom type. It's more effect of the sonar geometry. Okay, so I'm going to put this guy back where it goes. And so that's the setting I want to run with. And so I could go through and I could click on the next line and repeat that whole process. But we've got a better way. So in SonarWiz, when I've got the gain settings I like on one line, it's easy to apply those settings to all the other lines in my project by using the Sonar File Manager. So when I come into the Sonar File Manager, the line that I've got selected, which is this last one here, I want to take the settings from that line and make all my other lines just like that one. So to do that, I use the Make Like Selected button. And you can take any of the settings from your reference line and apply it to your project. But in this particular case, all I care about is the EGN settings. I just want to take my EGN settings from my reference line and apply that to all the other lines in my project. So I'll press OK. And then this is it's a background process in SonarWiz. And if you look down at the bottom here, you might see a scroll bar kind of whizzing by there. And if I zoom out to the full extent of the project, you can kind of see what's going on here. This guy's left to do, and this one's left to do here. But as they fill in, the mosaic will start to look a little bit better and a lot more normalized than it had before. So let's just look at one of these lines in the the profile view, the digitizer view, the waterfall view, I guess. And you can kind of see that the normalization is pretty good. If I go back just to show you what the raw data look like without the processing, let's kind of scroll down here where it gets a little bit weaker, and kind of toggle back to the process data again. You can see it's quite a bit improved. So this is pretty much what you want to get to. You want to get to a good normalized mosaic, something that doesn't have a lot of geometric effects from the sonar. Yeah, and this is kind of where I'm going to hand over to Matt and have him take control and take you through the starting process. I guess just one thing before I do. The other people ask this question a lot too. Does it matter what color I'm using for the Seabed classification? No, it makes no difference at all whether you're using a grayscale palette or a colored palette. It's just really the way that you process the data with the gains and bottom tracking. Those are the most important things. So Matt, are you still there?
Yeah, I'm there.
Okay, so I'm going to try to give you control here. And okay, so you should have control now, I think.
Okay. So something's coming up on my side. So while this is starting, I'll say hi to everyone. Can everyone hear me, I suppose, is the question then?
I can hear you fine.
You can hear me fine. And can you see my screen with my mouse moving around?
Yes, and we can see your screen. And yes, Christian and Rob, they all say they can hear you too.
Excellent.
Yeah.
Right. I will start then and stop me if there's any problems. Okay, so on my screen I pretty much got the same data as John. We're obviously in separate continents, so this is just a copy of the data set that John processed earlier on. It should look very similar. So what we're going to try and do is to assign different parts of this map. So just looking at that map, you can see there's an area over here which looks like something, an area over here that looks like something else. And kind of in between we can see there's places which are a little bit different. You can see down here there's what looks like some kind of man-made feature. That's highly linear. So all the Seabed classification is doing, there's nothing magic. It can't actually really work out what's sand or what's mud or whatever. It can just divide those into areas, really just to kind of as an aid to what the geophysicists might do to separate what different kinds of seabed type you might have down there are. Okay, so let's have a run through that then. So I'll just minimize this a little. Okay. So to get to the Seabed classification, we stick on Post-Processing and the classification button. First time you run that, you have a bit of a warning, just to say it's in early stages. I think it's reasonably stable now, but you don't want anybody to get upset. If I click on the Don't Ask Me Again, then I won't get that dialog each time I open up the classification button. Okay, so we can immediately see here we've got a few areas. On the left we've got some buttons marked Operation that says what we do. This blank area here, we'll see that fill up with information about what's going on. And down the bottom there's some images that you can see. We'll ignore those for the moment because I'm going to replace those. So if I click on Settings, first of all, and then what I'm going to do is just to start with the default settings. So I click on Defaults, it says, are you sure? And I say yes. I'm going to make one change, which I'm going to stop it exporting the polygons. So I'll just remove that. And the reason for that is that it can take a bit of time. It loads in an external library which can take a bit of memory and it can just get in our way, but I'll show you how that works in a moment. So I'll save that and I'm just going to click on Run All. And we should see the process of what's going on. So it says it's starting the training process, and there's a progress bar. It says that's completed, and it's now classifying. It's running the classification in 4 separate threads, 4 core machine here, so it's divided that up for me, and it's telling me how it's got on with processing each of the separate survey lines. The way it works is it processes each survey line separately, classifies each one separately, and then merges the results together. So there's the merge process. It then filters that merged image, and now it's completed. So what we can now do to look at that result is click on, I'm going to look at, it's produced 2 images, one from the output of the straight merge process and one from the filter. I'll explain those in a moment, but we'll just take the ordinary merge one for the moment. That's the first stage. Click Add as Base Map. Now if I close that, that's a base map, so it's underneath the main image, but we can peel back the main image with this button here, the Peel tool, and just peel that back, and we can see that classification map that is generated underneath. So we can see there's 2 colors, so it's found 2 classes there, which is sort of what you imagine by eye to find, and it's kind of divided those up in the areas I waved my mouse. So we've done reasonably well so far. And we can have a look at that. We can check that by zooming in on this chosen area. I'm going to zoom in on 2 areas here. Just zoom in first of all on this area where it's going from one class to the other. See if that's making sense. I'll use my peel tool again. And again we can see how there is where it looks like one area to the eye. The classification process has divided that up into another area, and when it looks like that darker part, it's left as blue. So that's fine. A couple of things to point out there though. First of all, in my data set I don't think I've got the EGN quite right, and we can see there's a fair amount of artifacting here. So in the center here I think we can see that central area, which is a bit kind of brighter, has a bit more texture. That's clustering around the center of the survey line, which runs along here. So that's likely to be a kind of processing artifact, or an artifact of the sonar itself, rather than a true feature. And we can see that actually the Seabed classification has sort of picked up on that and said, oh, I think that class runs through the middle of that, whereas just imagining how the geophysics works, they'd say, well, that's probably not quite right. So that's something we can look at to deal with in a moment. If I zoom right back out again and zoom into the area, I said this is probably a man-made feature here, so have a closer look at it. And again, we can see there's probably like to be a pipeline coming up through here, dividing it into 2 places here perhaps. So let's peel back and see how that's done there. Again, so it's kind of found that okay. We haven't quite got enough resolution on our process really to pick that out. And again, there's another area here where we perhaps got a little bit of artifacting in there that really perhaps what we want to do is go back into the Sidescan image itself, Sidescan file itself, and perhaps remove or reprocess that. But we can let that go for the moment. Okay, so that's the general process there. Let's go back to the classification map. I said that was the merged image. Let's remove that from the base map by clicking on that and have a look at the filtered one. Add that as a base map and close there. Now, for the classification, what we don't really want to do is to replicate the image itself. We want to divide up into broad brush areas to say this area is roughly one kind of seabed, the other area is another kind of seabed. So if I now peel back on there, we can see that my filtered area has done just that. It's said it's given me a much more kind of broad brush area. Roughly round about this area is one class, roughly round about the other area is another class. We still have a few areas here where perhaps there's some along track features there that aren't real seabed, but are sort of coming through as artifacts of the image. And the way to deal with those is to go back through the stuff that John has just shown you, have another look at that EGN process. Well, that's not really what we're about today, so I'll let that go. Okay, so that's kind of shown how the classification works. One more thing was the bit that I disabled, I can now show you, which is to generate the polygons for each class. So we're just going to create a DXF image, a vector image for each class. We're just going to draw lines around it. So if I save that now and click on export, that's the bit that exports to a DXF file. That's, as I said, perhaps going to take a little bit longer. It's actually a memory issue on the computer, and because I'm running the webinar application, that's using a bit more memory. So that's going to take a little while to run. We'll let that run away in the background there. That's finished. So if I close that and refresh the screen with this button down here, we should now be able to see we've got these lines around here. Let's zoom back in again. Zoom back into this area, and we can see how it's generated polygons around those class areas. So that's something we could then export into a separate report or something if we wanted to. So we can immediately, if we're going to write a report and say we've surveyed this area, and in this geographical area is one kind of seabed, in that geographical area is another one. We've got something to go into our report, draw lines around, and we can create maps and report to whoever wanted that information. That information, by the way, is hidden. If I open up the project, so in my case, the projects, each separate project goes into a file on your computer called SonarWiz projects. This one's called SC1, and it's created in there a subdirectory called classify, and we can immediately see that I have these are DXF files, and I can take those, export those, and do something else with them if I want to. Okay, so that's where all that information is hiding. Okay, so what else can we do with this that might be interesting and useful? So first of all, I'm going to get rid of those images that are shown on the screen. The reason for that is that because they're shown on the screen, the computer won't replicate them. Let's make this smaller again so I can see what's going on. So if I go to the Maps tab, click on the Map Manager, it's showing the map files, so there's two DXF files, one for each class, and the TIFF file, the filtered image. If I highlight all of those and go Remove, I'm ready to go on another set of settings. Okay, back to the Post-Processing, Classification again, and bring up the settings. Now what I'm going to do is to just see if I can get a little bit more resolution. Suppose on that man-made feature I wanted to resolve that a little better. What I can do is change the resolution that I'm using. So there's two things to look at here, a window size and a window step. Now what's happening here is that the classification process is working in little groups of pixels, taking a window of pixels and classifying within each window. So I'm getting one little colored square, in this case for a 15 by 15 pixel window. So if I want to have smaller pixels and smaller resolutions, it's go from 15 down to 9. The window step says that before starting the next window, I'm going to step along. Well, previously I was going along by 11 pixels. It's probably a good idea to make my window step size a little smaller than the window size. I'll make that 7. Okay, so we've got a bit of overlap between them, so there's no gaps there. Incidentally, it has a central pixel and a number of outer ones, so it tends to prefer odd numbers. But if you put an even number in, it'll round down to the next odd number. Let's take off the polygons again for speed. I'll save that, and I'll do run all. Now the immediate thing we'll see is it's going to run a little more slowly. Set up the completed. is the classification running. So it's still reading, but it is noticeably slower than before when we had a larger window size and a larger step size. It's the step size that controls the speed, because that's just the number of separate operations. In fact, it goes with the square of the step size because it has to step along in both easting and northing, if you like, on the map. So there, that's completed. So if we now take our new merged image, add that as a base map again, close and zoom in, use our peel back, we can see now we're picking up those a lot more individual pixels. We've got that higher resolution we were after. We can see around this area where I'm peeling back now, you can see it's picking up those little clusters, which could well be some kind of perhaps biological feature on the seabed, maybe some kind of reef or something, I don't know. So it's found those as separate little pixels. So if that's what you wanted to do, you're able to do that. So you've got to apply a little bit of judgment. What kind of scale? Here's the one just on the arrow there. There's a little something which is obviously coming up. So you've got to use your own kind of judgment to say, what kind of scale do I want to apply? Let's zoom right back out and look at that man-made feature again. And we should see that, again, it's picked that out in a little bit more resolution. Okay, so there we are. It's got a bit more of that. We can see perhaps the debris field around that or something. So it's dividing that up, if that's what we want to do. It's up to us to decide what kind of resolution we want and how we're going to show that. Okay, that's fair enough. Incidentally, of course, if we go back to let's remove that one and have a look at the merged image, again, we've got a higher resolution on that, a higher resolution on the previous filtered image, but it's still taken out some of the bittiness of that. But this time you can see it's actually picked out that pipeline quite nicely as a separate kind of class image, if that's what we wanted to do. Okay, so far so good. Let's go back and remove those images again use the map manager again and remove that. So that's away from the image again, and we can overwrite that merged image. Go back to the post-processing and the classification. Now we've got some more options here. Now that was using what I'm calling a simple texture set. We can actually get a bit more scope out of the whole classification process now by using a bunch of different textures. I'm going to use something called gray level co-occurrence matrix, or GLCM textures. Okay, I think I'll go back to my 15 and 11 for speed. So window size 15, so I'm going to look within individual windows of 15 pixels and step again on 11 between those, so it'll speed things up. Okay, I'll still turn off the generate polygons for a moment and I'll run that all. Now the GLCM runs a little bit more slowly, so I'm going to talk a little bit about how that works. I won't go into too much detail about the gray level co-occurrence matrix. If you look that up on Wikipedia, there's some quite good articles there, or wherever you prefer on the web. But essentially what we're doing is comparing adjacent pixels and statistics of how often one pixel is the same color. So it's a kind of higher resolution. Basically statistics on a whole window. The GLCM process is actually comparing adjacent pixels within the image. So it's actually getting a bit more detail out of that image processing. While it's running, I'm just going to run just a quick PowerPoint on that, if you can all see that. So when I talk about texture, texture is simply a way of statistically measuring something about the pixels, the image within one of my little boxes I'm drawing on the image to pick something out. So what I'm calling is the simple measures. Those are whole box measures. They measure something about the whole box. And two things are really quite useful are the standard deviation, or the amount of noise, or the entropy, which is the amount of order. And thirdly, the intensity. That's just how bright or dark is that image. The GLCM, as I said, compares adjacent pixels. I won't go into the detail. There is a fair amount of detail on the SonarWiz menu, SonarWiz help file. Okay, so if we take just one, let's say standard deviation, and scale it between the result we get from 0 to 1, we can draw an X where that is. So we can just put a number on that. If we now take another one, say entropy, and scale that one, is we can draw a point on a graph. And we can have more textures. More than about 6 gets a bit silly. I think currently the program limits you to 6 separate textures simply because it just uses up too much memory and gets too slow. But we can create a point on a graph. And we can carry on doing that for all the other points in the image. So here we are with 6 separate points, and they've all got their own points on that graph. And now what we can do is to say, well, they seem to have clustered together. The idea is that each cluster represents a particular kind of texture, a particular kind of position on the image that has a particular look. So that's my class 1, and these ones over here I'm calling class 2. And that's the output of the training process. So the training process gets my map, my class map, and draws boxes around that says if they fall into here, that's class 1. If they fall into there, that's class 1 in that one, class 2 in that one. So when I'm actually doing my classification, I start again with the same classification map, and for each pixel I find out where it is lies on that. If it falls into that area, it's class 1. If it's in that area, it's class 2. And that's it. So for each of my images there, I create a classified output. Okay, so let's go back to SonarWiz, and let's run all of those. So let's have a look at that again and add that as a base map, and have a look at that. Now, first of all, one thing we can see there is that there are more colors. It's created more than 2 classes. So let's zoom in and see what we think of that. Okay, and peel back. Now, first of all, we can see that although it has generated some classes, and if you look at that carefully, you can kind of agree that, yeah, where there's one particular color it's picked, there is something different. The one thing I would say about this is that most of those are a long track. In other words, we've got more kind of artifacting going on. Okay, but there are some cases where there are a particular kind of objects. I've seen cases where if you are looking for particular objects of interest on the seabed, say mine-like objects or something, then they can get picked out as a separate class. Okay, so in this case, I want to actually, although it has actually done something very interesting, that it's not useful in the sense that it's picking out really artifacts in what's different there. But we can see that there's something interesting there, and it's kind of picked out those groups really quite nicely. Let's go back to my classification, go back to the settings, and sorry, first of all, I want to remove that from the base map. Okay, so that's now I've gone and go back to the settings. What I'm now going to do, I'm going to say, that was all very interesting, thank you very much, but actually I only want 2 classes. So it says 2 classes, I'm going to enter the number 2 and say that's fine, that's what I want. I'm going to save that, and I'm going to just run the whole process again. Okay, so this time it should repeat the whole thing and just generate my 2 separate classes.
Matt, could I ask you a question?
Yes, certainly.
One of the attendees has a good question, and that is, how does a classification pick the number of classes? Like when you ran it through the first time, you had 6 in the settings, but you only got 2 classes generated.
So what I should have done actually is show you under the hood what's going on there. What it does, when it classes, so if you remember I showed you, let's pick up this, go back one on here. Okay, where it picks those class boxes, it actually decides how strong each class area is. In actual fact, it produces quite a large number initially, and then it thins those down automatically. It produces a quality figure for each class. So it might be on the basis of how many points it's got, it might be on the basis of how steep a kind of mountain it is, or how spread out the points are. So it puts them down in order. So if I only ask for 2, then it gives me the 2 strongest classes. If I ask for 6, it gives me the 6 strongest classes, and so on. Yeah, so it's just taking its own decision on what it thinks is a good class. Does that answer the question?
Well, the first time when you ran it through, in the settings there were 6. We asked for 6 classes, but
yeah.
In effect we only got 2 back.
Yes, that's right. But that's because using the it uses a quality measure to remove all classes which just don't cut the biscuit, don't cut the mustard to start with.
Okay. Well, that
okay, so it's automatically running that quality process. With the first time I did it, it happened that it could only pick 2 classes that it liked. When I ran with the GLCM process, it was able to pick up some more classes that actually were different from each other. And like I said, I think looking at the image we had, I'd agree with it. They were different to each other. They were perfectly valid classes as compared to the image, but a lot of them were just down to weaknesses in, just the fact on this particular image set, I hadn't done such a good job as John at running that EGN process, getting the settings quite right, and removing those long track artifacts. What I'll do in a moment is quickly run that again and show you how you can edit that class map though and make your own decisions on what's good and what's bad. But if I now pick my merged image, add that as a base map, close that and zoom in, we can see we're back to 2 classes again. We've now got a fairly kind of high resolution comparison. We're actually picking out individual areas here again. It's actually used a different pair of colors, but you can see that little area there. It's kind of picked that out. So one interesting thing about the GLCM is that you don't need to use quite such a fine resolution to get a similar kind of result. But one thing I would say about all of this is that to get exactly what you want, it's usually worth having a bit of an experiment and trying different things out. Let's zoom back in again here to the man-made object here. That was probably a pipeline, and pick that again. And you can see again that it's made a reasonable job at picking that out. This bit of pipeline at the top there, it's picked that out. So again, the GLCM is a way of getting a little bit more resolution. So 2 ways of getting resolution with this. One is to use the standard texturers, the ones that use the disks on the whole individual pixel we can see on the right of the screen here. That's my windows for Seabed Classification, and just using smaller box on the standard. Or you can use the GLCM process, which gives you a higher resolution within each box. Okay, well, we're starting to run out of time here on my bit, otherwise we won't have time for questions. What I can do is just quickly show you a couple more of the options that we got on the Seabed Classification before handing back to questions. So let's have a look at these settings. First of all, we've got this Manage Classes box. I'll click on that. It's only going to show, but it's going to show 3 classes. Black is the null class, which you get when there was no image to produce. So that's always the case, but I could change the color of the null class if I wanted. I can edit each of these. Or if I don't like one of them, I can just click on it and click delete. So I don't have to delete the weakest one. I can delete whichever one I want. If I edit it, I can change its color. So I could change from blue to brown. I could give it a name, and that'll come out in any output reporting we do. So I might decide perhaps that's mud. I don't know actually what it is in this case. Yeah, so that's really just helps with the output reporting and so on. So if I now save that and close that, what I'll need to do is to rerun the merge process to get the new colors. We're running out of time, so I don't have time to do that. One more thing quickly to show you, or a couple more things. The near and far range on the Sidescan often don't give particularly good results, so I can trim those. Currently, that's the near and far 5% are ignored in the Seabed classification. If I decide my nadir, my central region, needs a bit more trimming, I can change that to 10%. That will ignore the near 10%. On the training, normally I just decide that one line will do, so I just run the training process on one line to speed things up. But if I remove that, it'll train on the whole image and then classify on the whole image. And then the last thing on this left-hand side here, I have the option to, I can, rather than just using the GRCM, I can use a different selection. If I now pick on the advanced selection and click on texture as advanced, you'll see we've got a whole palette of different kinds of statistical measure I can use. The thing to do is to have a look in the manual to try and understand how those work if you want to play with that. But I click on these, I can produce any kind of mixture I want. I click on OK, and that'll produce a different kind of result that might work. But to kind of simplify that a little bit, I've created a custom selection 1 and custom selection 2. Those are settings which I found have worked fairly well on different kinds of image, but to produce different kinds of results. And again, it's very much a kind of suck it and see thing to try out. Okay, so I think I'm kind of out of time with all of that. So probably the thing to do is to hand back to John and see if there's any questions, and then I can deal with, well, the details according to the questions I get.
Okay, and Matt, actually you might want to keep control just for a minute, because I can see the questions and I can just refer them to you. I've been trying to answer them as we go along, but there's one here that I think is an interesting one, and this question is there a way of telling the process what color all the shadows have to stop it from making shadows a class? So, you know, with Sidescan, the way you light up a target will create a shadow, you know, on the opposite side, and so how do you prevent the classification, or can you prevent the classification process from making that a class of its own, that shadow?
Not really. I mean, what's happening is that the classification process is just using the image pixels, so it can't actually work out what that is. But what you can do, while we're talking, let's just rerun that classification. With the default settings, so I'm going back to 6 here, but running, let's say, the custom selection 1. While I'm talking, I'll save that and I'll run it. Run all. So we can see how we can edit that. What will sometimes happen is that all of the shadows will come out as a particular class, because they will tend to be very black, and so they sometimes come out with a class of their own. So if you wanted to leave it that way, of course, you can give them a particular color. Or if you decide that actually I want to merge those in with adjacent areas, what I can do is just delete, and it will then try to assign the it would have gone in this shadow.
Matt, when you're When your data is processing, we can't. The audio breaks up.
Yeah, I think it's that. Yeah, it's probably the video that's trying to transmit your screen there when the progress bar is going. It looks like it's kind of stomping on the video or the audio a little bit. Let's get probably the guy in room 504 that's just logged on.
A little bit of drop out. Yeah.
Right. So Matt, we missed everything that you just said.
All right. Okay. Let's start again then. I don't know what happened there. Yeah. So the question was. Beg your pardon there.
Oh, Matt, I was just going to say when the data is processing, when you're processing your data, the audio breaks up, so no one can hear what you're saying. So we sort of have to wait for the data to process.
Okay. So I can't talk while we're doing that. Okay. Well, the classification is almost finished. Right. Okay, great. So the question was, suppose we've got shadows in the image. Can we do anything with that? Well, first of all, the answer was the classification process itself doesn't know a priori whether part of an image, which is a shadow, is a shadow. There's nothing special about that. We could have some shadows down here, maybe in this area here. So that's possibly a shadow there. As far as the process is concerned, let's look at that. As far as the process is concerned, that's just a different kind of class. In this case, though, it's decided actually that area of shadow is the same class as this stuff over here. It's just fairly flat stuff with nothing in that. But what you can do is you could perhaps play with the EGN process or other kinds of the processing tools to try and bring out what is a shadow. And in that case, it might decide actually it can actually tell that shadow is a particular class. Now, once you've done that, you could go back to that, let's bring up the settings again, manage classes. If you could identify it's coming up as a particular color, say perhaps my shadow is always coming up as red, I can then edit that, and I could call it shadow if I wanted to, or I could give it a particular color. So that's the first thing I could do. So I can give that a particular color and a particular description. Too many colors here to choose from, but, whatever. So I've got the ability to do that. So I can identify those. The other thing I could do, though, is I could say I don't want to show any of those. So everything that did come up in a shadow, I'm going to delete that class. Click on delete, and that's gone. And now what will happen, any pixel that would have fallen into that will now come into the color that showed there before. Now what I now need to do to rerun that, so what that's done, I've edited the results of my training. So first of all, I need to tell it not to retrain when I click on run all. So I click on that button there, so it's not retraining on run all, save that, and then I click on run all again. So what that's sorry, I'll abort that because you can't hear me. But when I click on run all, then it will run through the whole process again without having done the train and reallocate everything to my new edited class map. Okay, I think that's the best I can answer that question for now. Is there anything else?
Okay. All right. Let's see. We've got a couple of questions that are similar, so I think maybe we'll hit this one. Is there a way to mask along track artifacts? And I think the first approach to masking along track artifacts is to try to get rid of them so you can't see them in the sonar data in the first place, right? So
that's right, yes.
So the best thing to try to do is to maybe nudge the bottom tracker a little bit deeper, and then rebuild your EGN table and reapply EGN. That's sort of the first tact. And then, as I mentioned at the introduction, we're planning a kind of another development bash on this stuff in December. And one of the things that Matt and I talked about earlier this week was the ability to, after you've generated polygons, you can actually clearly see that, okay, I don't want that polygon. That's bogus, or that's not really a class. The ability to manually go in and click on the polygon and say delete that, and then delete that portion of the underlying class. So that's something I think we're going to try to put in the user interface in the next round of stuff, because yeah, it's impossible to get it perfect, but you don't want to get rid of all the automated functions, but you kind of need some way to get in there and then manually correct what the automated process has done. Do you have anything to that, Matt?
Yes, there's a third thing you can do. If quite often the long track artifacts are coming along in the middle of the images. So you can see here there's some long track artifacting going along the middle of the track. So what I can do is to say, well, I'm just going to ignore what happens in the middle of that area. So I go to classification, bring up the settings, and I just increase that nadir trim, let's say to 20%. So what that's going to do is just ignore everything in that middle area. So if I can't correct it, I just get rid of it, and it's only going to classify on the bits further out. So that's quite a quick and easy way of doing that.
Okay. Yep. Yeah, that actually answers another question from someone that wanted to know if transparency would help apply. But the transparency function is just something that's in the GUI really, and not part of the underlying data. So I think the best thing is to use the nadir trimming and maybe the far field trimming, but certainly the nadir trimming
yes,
percentage function.
Yeah, I mean there is. That does bring out quite a good point, though, which is what's happening in the merge process. As I mentioned, it classifies each separate survey line as a separate image. Incidentally, you can see all of those in that classify folder within the SonarWiz project class, and they're down here. So if we want to see what it's doing on an individual image, so let's pick on that one. That's the first line, and that's the grayscale image that's produced. You can zoom in, you can see that's just the grayscale, and that's what it's using. It's just using, in effect, a number, which I'm showing here. It's just a grayscale, and that brings up John's point that it doesn't really matter what color map you use, because the color map is only a way of representing the image number that appears, which is showing there. And now if I click one to the right, you can see the classification it's given there. In this case, it's classified that one all as one image. Okay, that's a better example. So you can see those. Now, in the merge process, what it does, it overlays those in the geographic sense. So it works out where each pixel is and draws it on the screen. Now, there's no way of merging classes. A class is just an arbitrary number. It's not a quantity that you can take an average from. It's either in class 1 or class 2. There is no class 1.5. So what it does, it just overlays them in order. So it's the equivalent of, I think you've got this view process. Help me here, John. You've got the ability to, yeah, the overlap mode. So in this case, it's drawing them in order and covering them up, but you can shine through, you can create averages, and so on. So at the merge process, it just, when it writes in a new line, it just puts them in order. Now, the only thing you can do with that in the post-processing, if you bring up the file manager, I think you can change the order in which these appear. Can you, John?
Oh yeah, you can actually. You don't even have to go in the file manager and do that. You can do that right in the right on the map. You can say bring to front or send to back.
Right. Okay. Yeah. So if you take one particular line, how do you do that?
Yeah. You just click on the line and then
click on the line. Right click
and say order.
And order down here. And I see, so if we do send to back. Right, okay, great. So if you do that and reclassify, what it will now do is that the lines that were around the one I sent to the back of the image will be also overridden where there's a disagreement by the adjacent lines. So that's another way you can play with that. You can choose which line is going to appear on top in the final merged classification image.
Matt, I was wondering if you have time for one last question here.
Yeah,
this is from also from a guy in the UK. So his comment is reflectivity is angle and seafloor type dependent, with different seafloor types responding at different angles in different ways to us. So a sand at far offset angle will give a different response to a clay, say. Is there any way of thinking about this in terms of entropy?
In terms of what, sorry?
Entropy.
Entropy. How the entropy responds to... Not the way we're doing this. I mean, there are... One thing to say about the SonarWiz Seabed classification is that it doesn't try to do anything too complex. What it's doing is in effect, simple image processing. And it's that whole things like the EGN process that you used is a good way of doing it. But what they're trying to do is to normalize that out so that things close in look similar to things far out. Now, a possible future extension of this could be to try to use the angular information as well as the brightness to try and get some more information out of that. And indeed, yes, I mean, if you try to draw a graph of the angle reflectivity with the the reflectivity you're getting against the angle of incidence, then you can get some information about Seabed classification out of that. In this case, we're not doing that. I suspect you would want to do that as an extension of a system which is using the angle, in other words, the bathymetry information as well. And this is really designed to work on pure Sidescan systems, where you're taking kind of flat seabed approximation, but I rather suspect, given that most seabeds aren't really flat enough for that approximation to work, such a thing would have to wait for bathymetry information to come into SonarWiz as well as the Sidescan.
Right. Okay, well, great. Well, as I mentioned, there were a few questions. Actually, we had quite a few questions, and I have tried to answer some, but there are several that I didn't get to. So look for an email in the next, probably in the next day here from me and or Matt, and we'll try to get all of those answered. So I just want to thank everyone again for taking the time for this, and again, you know, we really appreciate your input. If you've got, some people have already made some suggestions in the questions session today about what how to make it better, and we definitely want to factor that into our next development round. So I guess that's just thanks again, and I think that's everything for today. Until the next webinar, I guess we'll see you all soon.
Okay, bye everyone.